You take a moment to try these two problems on your own, either on a dry erase board or on scrap paper. And when you've got an answer for each, then go ahead and resume the video and we'll go over these answers together. So in A, the limit as x approaches 2 of the quantity x squared plus 5x minus 14 divided by the quantity x minus 2. If I try direct substitution, 2 minus 2 gives me a 0 in the denominator, and so that would be an indeterminate form. We're going to try factoring the numerator to see if we can simplify this rational expression further. So 1 times negative 14 is negative 14. We want factors of negative 14 that add to equal 5, and that would be a 7 and a negative 2. And so we're evaluating the limit as x approaches 2. In the numerator, we have a factor of x plus 7, a factor of x minus 2, and in the denominator, we have a factor of x minus 2. So those x minus 2's will cancel, leaving us with the limit as x approaches 2 of the function x plus 7. That's a linear function on the graph with a hole at 2. To find the limit as we approach that hole, the x is going to get substituted with a 2 in direct substitution, and 2 plus 7 is equal to 9. Okay, then in example B, if I substitute a negative 1 in for x in the numerator, negative 1 plus 1 is 0. And the denominator will have a 2, then minus 1, minus a negative 1 is going to be 3. Minus 3 is 0, and 0 over 0 is that indeterminate form. So we're going to need to factor that denominator. And 2 times negative 3 is negative 6. We want factors of negative 6 that add to equal negative 1. That'd be negative 3 and positive 2. Since the leading coefficient is greater than 1, I'll use a box to organize my factors. And the first term of the quadratic trinomial goes in the first box. The constant, or the last term, goes in the last box, and then the diagonal gets those factors from my crisscross, a negative 3x and a positive 2x. So looking for my greatest common factor across the first row, I can pull out an x. The second row, I can pull out a 1. The first column, a 2x, and the second column, a negative 3. So I'll be evaluating the limit as x approaches negative 1, and the numerator is an x plus 1, and in the denominator I have a factor of x plus 1 and a factor of 2x minus 3. The x plus 1 factors will cancel, leaving a 1 in the numerator. So I'll be evaluating the limit as x approaches negative 1 of 1 divided by the quantity 2x minus 3. And now we can evaluate that using direct substitution. Let's clean up that numerator there. So 1. There we go. And that's going to be 1 divided by 2 times negative 1 minus 3. There we go. Negative 1/5.